Okay, so we are now going to find, we've got all of these points, like f of 0, then the transition points, pi over 6, 2 pi over 3, 7 pi over 6, we've got 5 pi over 3, and then our endpoint that they gave us was 2 pi. All right, so my function, I've got, I'm going to write this out, so root 3 and then sine of 0 minus cosine of 0. All right, so I'm going to take these. This is my function. I can just kind of reuse it as I'm going. So sine of 0 is 0, so that whole thing is 0. And then minus the cosine of 0 will be minus 1. So that's a negative 1. So now here's my function. I just know these are x's. So I have root 3 times the sine of pi over 6, which is 1/2. And then minus the cosine of pi over 6, which is root 3 over 2. So I have root 3 over 2 minus root 3 over 2. That's 0. Next one, root 3 times the sine of 2 pi over 3, which I'm in the second quadrant, so that would be a positive root 3 over 2, minus the cosine of 2 pi over 3, again in the second quadrant, so that would be a negative 1/2. So this is 3/2 minus negative 1/2, so that's a positive 4/2, which is 2. 7 pi over 6 is my next one. So root 3 times the sine of 7 pi over 6, which is a negative 1/2, minus the cosine of 7 pi over 6, which is a negative root 3 over 2. Okay, so here's a negative root 3 over 2 plus root 3 over 2. So that's 0. 5 pi over 3, I have root 3 times the sine of 5 pi over 3, which is a negative root 3 over 2. And then minus the cosine of 5 pi over 3, which is a positive 1/2. Okay, so negative 3/2 minus 1/2 is a negative 2. Then 2 pi, whatever I get for 0, I get for 2 pi. So that's a negative 1. Okay, so I'm going to take all these values. I'm going to plot everything. I've got all sorts of crazy things going on. I'm going to get a fresh sheet of paper so I can kind of transfer back and forth between these points and then the sign chart and everything like that. Okay, so let's set this up. Okay, so I've got 1, 2, negative 1, negative 2. Go all the way to 2 pi, so let's start splitting things up. So this is, that'll be pi. Then I can use that to split into thirds. So here's pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, and then I need the sixth as well. Okay, so here's pi over 6, halfway between 0 and pi over 3. And then I need 2 pi over 3, which I already had, I just didn't label it yet. 7 pi over 6 would be right there. 5 pi over 3, and then of course my endpoint of 2 pi. So I'm going to plot these points right here. Okay, so at 0, I'm down here at negative 1. Pi over 6, I'm at 0. 2 pi over 3, I'm all the way up at the top at 2. It's a maximum. 7 pi over 6, I'm back at 0. 5 pi over 3, I'm down here at negative 2. That's a minimum. And then I end my graph the same place I started at negative 1. Okay, so I've got all these points. Now I'm going to get the sign chart back on the screen so I know what my shapes are supposed to look like. Alright, so lots of craziness going on here. So from 0 to pi over 6, I am supposed to be increasing and concave up. Okay, so sort of like that. This darn video cut me off again. I swear I'm having the hardest time with this for some reason. So I'm just going to put, I know the graph is already drawn. Sorry, I'm sure you will be able to follow along. I'm going to put the sign chart and the graph on the same screen so you guys can just see everything that I'm looking at here. So this next little chunk that goes between pi over 6 and 2 pi over 3, you can see on the chart we've got a positive first derivative, which means my graph should be increasing. A negative second derivative means I should be concave down. So that's this little strip of the graph right here. And then here I have a max, which you can see on my first derivative sign chart. My first derivative changes from positive to negative at this point right here. Notice though my concavity is still negative, and so I'm still concave down throughout this whole shape, but I change from increasing to decreasing, which makes this a max. So in this little piece, I'm a double negative set as decreasing and concave down. Right here at pi over 6, I have an inflection point, which you can see on the second derivative sign chart. My concavity changes. There's a sign change for the second derivative. Again, though, my decreasing feature has not changed, though, because I still have a negative first derivative. And then right here, what changes is the first derivative. So that is why this point right here at 5 pi over 3 is a local min. My first derivative changes from negative to positive, so this ends up being a min. But again, my concavity is still positive, and so this whole shape is still concave up. And I end here at 2 pi because that's the boundary that they give us on this graph. All right, so let's hope I can merge these videos together.